5 men died in that Sherman before anyone understood why. Not in a way that made sense by the numbers. Not in a way that the intelligence briefings had prepared anyone for. The tank was sitting in a field outside the Belgian town of Mons on the morning of September 19, 1944, and it had been hit once, a single shot. The entry hole in the frontal plate was clean and centered, and the round had passed through the armor, through the crew compartment, through the rear wall, and continued into the field behind the tank for another 60 meters before burying itself in the mud. The fire started from the inside. Nobody got out. The field report listed the range as approximately 1,800 to 2,000 meters. That number is what started everything. Captain Frank Wells was 31 years old, a ballistics engineer from Dayton, Ohio, and he had spent 2 years at Aberdeen Proving Ground doing the kind of work that wins no medals and receives no attention until something goes wrong that nobody can explain. He tested captured German ammunition. He measured. He calculated. He wrote reports. Most of those reports sat in filing cabinets at rear area headquarters and were read, if they were read at all, by junior staff officers who summarized them into 2 sentences for people who had already made up their minds. Wells was not bitter about this. He was an engineer. He understood that the system processed information the way it processed everything else, slowly, selectively, and with a strong preference for conclusions that confirmed what was already believed. But when the report on the Mons tank crossed his desk, something in it would not leave him alone. 1,800 meters. He knew the KWK 36. He knew it the way a doctor knows a familiar disease, its performance at every range, its behavior against every armor thickness, its limits. And its limits at 1,800 meters against 76mm frontal plate were real. Not impossible, but not clean. Not a single shot that punched through steel like it was not there and kept going for 60 meters. That was not a gun working at the edge of its capability. That was a gun with energy to spare. The KWK 36 did not have energy to spare at 1,800 meters. Wells submitted a recovery request for whatever physical evidence remained at the site. 4 days later, a truck came back with 2 things: a section of hull plate cut from around the entry hole and a fragmented projectile recovered from the field where it had finally stopped. He examined the hull plate under a work lamp that evening. The penetration wound told him more than the field report had. Clean edges. No spalling around the entry point of the kind you see when a round is decelerating through armor and depositing energy into the plate itself. This round had not slowed down meaningfully on impact. It had gone through the steel the way a needle goes through fabric, with velocity left over, with authority. Whatever fired this shot was not struggling at 1,800 meters. It was comfortable there. Then he measured the projectile base. 88 millimeters in diameter. Correct, standard German caliber, nothing unexpected. But the body taper was wrong. Not slightly wrong, not a manufacturing variation within tolerance. Wrong in a way that indicated a different cartridge geometry entirely. Wells checked his reference files. He checked them again. The taper profile he was looking at did not match any 88 millimeter German tank round in his collection. It matched nothing he had documented in 2 years of working with captured ammunition. He applied for permission to inspect a captured Tiger 2 at the vehicle collection point outside Liège. The approval came back the next morning, which was unusual enough that he noted it in his log. The collection point was a field of broken machines. Burned hulks, stripped wrecks, vehicles that had been dragged off the battlefield and deposited here to wait for people like Wells to decide what they were worth. 3 Tiger IIs sat at the far end of the field. 2 were destroyed beyond examination. The third had been abandoned intact after a mechanical failure and had arrived at the collection point with its gun and breech assembly completely untouched. Wells climbed into the turret with a measuring tape and a set of calipers. He opened the breech and ran the measuring tape into the chamber. The number he read stopped him completely. 822 millimeters. He pulled the tape out and ran it again. Same number. He wrote it in his notebook and then sat in the turret and stared at it for a moment, because that number meant something that 2 years of Allied intelligence work had entirely missed. The Tiger I's KWK-36 was chambered for a cartridge 571 millimeters long. Wells knew that measurement without checking. He had handled hundreds of those rounds. The chamber in front of him was 251 millimeters longer. Not a refinement, not an upgrade. A completely different cartridge, a completely different pressure curve, a completely different weapon, wearing the same caliber designation on every document Allied intelligence had ever captured and translated. He did the arithmetic without writing it down, because he did not need to. A cartridge case 251 millimeters longer holds dramatically more propellant. More propellant generates higher chamber pressure. The barrel above him was 71 calibers long. The KWK-36 barrel was 56 calibers long. A longer barrel means a longer acceleration path for the projectile before it exits the muzzle. The combination of higher pressure and longer barrel does not produce marginally higher velocity. It produces a muzzle velocity roughly 300 to 350 meters per second, faster than the gun every Allied briefing had been describing as the Tiger's main armament. And here is what 300 meters per second of additional muzzle velocity means in practical terms. It means the penetration tables are wrong, every single one of them. The tables that told Sherman crews at what range they could expect German 88mm fire to fall short of their frontal armour. The tables that formed the basis for engagement doctrine, for positioning recommendations, for the tactical guidance that crews carried into combat and trusted with their lives. All of it was built on data from the KWK-36, the gun in the Tiger I, the gun that was no longer the gun they were fighting. The Tiger II had been in combat for months. It had been killing Allied tanks at ranges that should have been safe. And the analytical system had not caught it because both guns were labelled 88mm in the captured documents, and nobody had gone into a turret with a measuring tape to check whether the chamber matched the label. 5 men had died in that Sherman before anyone understood why. Wells now understood why. He climbed down from the turret and stood in the mud of that Belgian field with his notebook in his hand, and for the first time in 2 years of writing reports that nobody read, he felt something that was not methodical and was not precise. He felt the specific anger of a man who has just discovered that the people who trusted the system had been handed numbers that the system had never actually verified. He had a report to write. Colonel James Harrison read the report once, set it down, and stared at the wall for a moment. Then he picked it up and read it again. Then he called Wells directly, bypassing 2 levels of staff procedure, which Wells would later note in his log as unusual enough to be worth recording. Harrison asked one question, not a technical question, not a request for clarification, just 4 words. "Are you certain?" Wells said yes. Harrison said, "Do you understand what this means for every penetration table we have distributed to tank crews in the field?" Wells said he did. Harrison said nothing after that for long enough that Wells thought the line had dropped. Then Harrison said he would call back within the hour and hung up. He called back in 40 minutes. By then, he had apparently spoken to 3 other people because his voice had changed from the careful tone of a man processing new information to the tight, controlled tone of a man who has just understood the size of a problem and is deciding how to respond to it without alarming anyone. What Harrison had understood in those 40 minutes was this. The penetration tables distributed to Allied tank crews were not abstract documents. They were survival tools. A Sherman commander in the field made decisions based on those tables, at what range to engage, at what angle to present his armour, At what distance German 88mm fire could reasonably be expected to fall short of his frontal plate? Those decisions determined whether a crew lived or died, and every single one of those decisions had been calibrated against a gun that was no longer the gun those crews were facing. This had been true for months, but to understand how it happened, how an entire Allied intelligence system missed a weapon that had been killing their soldiers since the summer of 1944, you have to understand something about the way the number 88 entered the war in the first place, because the number did not start with tanks. It did not start with the Eastern Front or with Rommel's guns in the African desert. It started with a problem that had nothing to do with armour at all. It started with airplanes. The year is 1928. Germany is legally disarmed. The Treaty of Versailles has reduced the German military to a glorified border patrol, capped at 100,000 men, stripped of tanks and heavy artillery, watched by Allied inspection commissions whose job is to make certain Germany cannot rebuild the war machine that had bled Europe for 4 years. What those commissions did not anticipate was that Germany had routed its weapons development to foreign soil. In the Swedish city of Landskrona, a German arms company establishes what appears on paper to be a civilian manufacturing operation. Behind that paper is a shadow laboratory where German engineers are working on something the treaty explicitly forbids: a heavy anti-aircraft cannon capable of reaching enemy bombers at high altitude. The engineering requirements are specific and unforgiving. High muzzle velocity, because you are trying to hit a fast-moving aircraft before it escapes the engagement envelope. Flat trajectory, because calculating the lead angle on a diving bomber is already difficult enough. A light projectile moving extremely fast, because speed is the only variable that closes the distance in time. The caliber that emerges from these calculations is 88mm, not because 88mm is the perfect diameter for an anti-aircraft shell, because 88mm is what the math produced when German engineers in 1928 balanced manufacturing constraints against available propellant chemistry against the specific ballistic requirements of altitude engagement. It is a compromise. It is an engineering answer to a specific question about airplanes, not armour. The gun is called the Flak 18. It fires a cartridge 571mm long. It is designed entirely, completely and exclusively to shoot down aircraft. Now move forward to France, May 1940. German armour is cutting through the Ardennes, and the campaign is going almost exactly as planned, right up until the moment it is not. German tank crews pushing through the fields and towns of northern France encounter the British Matilda II. It is not a fast tank or a graceful one. It carries a small gun and it moves like a tractor, but its frontal armour is nearly 80mm thick, sloped and curved in ways that make the effective protection even higher than the raw number suggests. The standard German anti-tank gun of 1940 fires 37mm rounds that strike the Matilda's hull and bounce off. German crews are watching their shells ricochet at point-blank range. A tank that should be destroyed is driving through their fire and continuing forward. In desperation, German artillery commanders pulled their Flak 36 batteries, the direct successor to the original Landskrona gun, out of anti-aircraft positions, rotate them horizontal, and point them at British tanks. What happens next changes the entire trajectory of the war. The 88mm round, built in a Swedish shadow factory to intercept bombers at altitude, passes through the Matilda's frontal armour without meaningful resistance. Not a struggle. Not a marginal defeat of the protection. A clean, complete, almost contemptuous penetration of armour that had been stopping everything else the Germans had. A weapon designed for one purpose turns out to be devastatingly effective at a completely different one. Not because anyone planned it that way, but because high muzzle velocity is useful for reaching aircraft, and high muzzle velocity also happens to be useful for defeating steel. The physics overlap by accident. The message that went up through the German command structure after France was simple, and it never faded. The 88 works. Do not change the 88. 1 year later on the Eastern Front, the same story repeats itself on a scale that makes France look like a rehearsal. German panzer units rolling into Soviet territory in June 1941 encounter the KV-1, a vehicle with frontal armour over 70 mm that stops nearly every anti-tank gun in the German arsenal. The T-34 is appearing in numbers that alarm German planners. Standard equipment fails. And again, the Flak 36 is dragged into improvised anti-tank positions. And again, the accidental weapon performs magnificently in a role its designers never imagined. When German engineers are tasked with arming the Tiger I, they do not start from nothing. They take the Flak 36 cartridge, the 571mm case, the chamber geometry, the ballistic profile that has now proven itself in France and Russia, and they adapt it for a rotating tank turret. They call it the KWK-36. They change the mounting, the breech mechanism, the muzzle brake. They do not change the cartridge. They do not change the fundamental ballistic architecture, because there is no time to start over and because the gun already works. The Tiger I is a tank built around a rescued anti-aircraft cannon. That is not a criticism. The KWK-36 was extraordinarily effective. It killed Soviet armour at ranges where Soviet guns could not answer. It overwhelmed Allied tanks with a performance margin that seemed almost unfair. It made the Tiger one genuinely terrifying on every front it appeared on. But it was effective the way a tool is effective when you use it for something it was not designed for. It worked because the physics happened to cooperate. Every kill the Tiger I ever made was achieved by a gun that had been designed in Sweden to shoot down airplanes and ended up in a tank turret because nobody had a better option when it mattered most. Now it is 1943, and the accident is running out of road. Soviet armour is getting heavier every quarter. New designs are appearing with slope angles and protection levels that are pushing against the limits of what the KWK-36 can reliably defeat. The comfortable performance margins of 1941 are narrowing. German engineers are being asked a question their predecessors never had to answer seriously. What do we need to build from absolute zero, with no inherited compromises, to defeat armour that will exist 18 months from now? The answer is the KWK-43. Here is what that answer looks like in numbers. The KWK-43 fires a cartridge 822 mm long. The KWK-36 fired a cartridge 571 mm long. That difference of 251 mm is not a refinement. It is a completely different propellant charge generating completely different chamber pressure, driving a projectile down a barrel 71 calibers long instead of 56. The muzzle velocity of the KWK-43 is approximately 1,130 meters per second. The KWK-36 achieved roughly 800. At 1,000 meters, the KWK-43 penetrates approximately 193 millimeters of vertical armor. The KWK-36 at the same range penetrates approximately 138 millimeters. 138 millimeters versus 193 millimeters. That gap is not a percentage on a chart. That gap is the difference between a round that might defeat a well-angled piece of Soviet armor and a round that defeats it without the question even being interesting. The ammunition from one gun cannot be physically loaded into the other. The cartridges are incompatible. These weapons share one thing, and one thing only: the diameter of the hole at the end of the barrel. But in every captured German document that Allied intelligence had translated, both guns carried the same designation, 88 mm. And the conclusion that followed from that designation was logical, reasonable, and catastrophically wrong. The Tiger II carries an improved version of the Tiger I's gun. Same family. same lineage. Bigger, but related. The Germans knew exactly what they were doing when they kept the bore diameter at 88 millimeters. The industrial infrastructure for 88 millimeter barrel production was already built. Factories, tooling, supply chains, all calibrated to that bore size. Keeping the diameter while completely redesigning everything else meant carrying over some production capacity, and it meant something else, something quieter and more dangerous. It meant that commanders who already trusted the 88 would not ask questions about a weapon that sounded like a continuation of something they knew worked. They had built a completely new gun and hidden it behind a number that nobody would think to verify. Wells sat in that farmhouse outside Liège and looked at what was on his table, the fragmented projectile from the field at Mons, his notebook with 822 written in it and underlined twice, his reference files showing 571 millimeters for the KWK-36, the number he had memorized years ago, the number that every Allied penetration table was built on. He thought about the 5 men in the Sherman outside Mons. He thought about how many other Shermans had been hit at ranges that the tables said were safe. He thought about how many crews had made positioning decisions based on engagement distances that assumed a gun that was no longer the gun being fired at them. He thought about how long the Tiger II had been in combat. Since July. It was now October. 3 months of a weapon that Allied intelligence had been describing incorrectly to every tank crew in the field. The Germans had not just built a better gun. They had built a better gun, given it a familiar name, and watched as the entire Allied analytical system filed it under a category it had already processed and moved past. The label said 88. Everyone had already formed their opinion about 88. Nobody looked inside the chamber to check whether the gun behind the label was the same gun they thought they knew. It was not. It never had been. Between July and October 1944, Allied forces lost over 500 armoured vehicles on the Western Front to German 88mm fire. That number is not unusual by the standards of that campaign. Tanks were being destroyed every day across a front that stretched from the Channel coast to the German border. What makes that number significant is something that nobody in the official post-war accounting ever stated directly. A substantial portion of those vehicles were hit at ranges that the distributed tactical table said were outside the reliable performance envelope of the German 88mm tank gun. Crews had positioned themselves at distances they had been told were safe. They had made the calculations, they had followed the guidance, and they had burned anyway. The guidance was built on the wrong gun. Wells knew this by October 7th. His report was 14 pages, single-spaced, with chamber measurements, projectile analysis, and a direct recommendation that all existing Tiger II engagement guidance be withdrawn immediately and reissued. He marked it urgent. He attached a 1-page summary at the front for senior officers who would not read 14 pages regardless of what the pages contained. The first response came back in 5 days. A staff colonel at headquarters had reviewed the summary and returned it with a handwritten note in the margin. The note said, "Penetration tables have been verified by Aberdeen. Please confirm findings are not the result of measurement error." Measurement error. Wells had measured the chamber of a captured Tiger II with a calibrated instrument in front of 2 witnesses. He had cross-referenced the result against 2 years of documented reference data. The institutional response to 14 pages of physical evidence was to ask whether he had used the tape correctly. He wrote back the same day, 4 sentences, no measurement error, findings confirmed, recommendation stands, awaiting response. Another week passed, then another. What Wells was running into was not stupidity, it was not individual incompetence. It was something harder to fight than either of those things because it had no face and no name and could not be argued with directly. The Allied intelligence system had processed the Tiger 2 months earlier. It had captured German documents, identified the 88mm caliber designation, cross-referenced against the known KWK-36, and filed the Tiger II's armament under a category that already had an answer. The system had done exactly what large institutions do with information that appears familiar. It had stopped looking, not maliciously, not lazily. The analysts who processed those documents were competent professionals working under enormous pressure with incomplete information. But competent professionals working under pressure default to pattern recognition. They see a number they have seen before, and they reach for the file that already exists rather than opening a new one. The Tiger II's gun said 88mm. The file for 88mm German tank guns already existed. The Tiger II went into the file. Nobody measured the chamber until Wells did. And while the file sat closed, while the report moved through channels, while staff officers wrote notes in margins about measurement error, the tanks were burning at ranges the tables said were safe. This is the mechanism that Wells spent the winter of 1944 trying to document, not the engineering difference between the KWK-36 and the KWK-43, which was by then established beyond any reasonable dispute. But the deeper failure underneath the engineering failure, he called it the label problem. His argument was specific and uncomfortable. When an intelligence system identifies a weapon by a single measurable characteristic and uses that characteristic as its primary filing category, it creates a structural blind spot. Any new weapon that shares the characteristic inherits the old weapon's assessed performance. The new weapon gets the old weapon's penetration tables. The new weapon gets the old weapon's engagement recommendations, and nobody checks whether the inheritance is accurate, because checking would require admitting that the previous assessment was incomplete. The Germans had kept the bore diameter at 88mm for industrial reasons. The tooling and production infrastructure already existed for that bore size, and carrying it over into the KWK-43 saved manufacturing capacity. Wells was careful not to overstate this point. He did not claim there was a deliberate deception operation built around the caliber designation, but he noted something that was harder to dismiss than a claim of deliberate deception. Whether by design or by industrial convenience, the effect was identical to what a deliberate deception would have produced. A weapon with completely different performance characteristics had been deployed behind the cover of a familiar number. The system on the other side had accepted the cover without inspection, and the result of that acceptance was measured not in analytical errors, but in burning vehicles and dead crews at distances that the tables said were safe. In late October, with Allied pressure mounting on multiple fronts and German logistics collapsing faster than any technical advantage could compensate for, the command structure quietly incorporated Wells' findings into updated guidance. There was no formal announcement that the previous tables had been wrong. There was no acknowledgement of the gap between July and October. The correction happened the way institutional corrections usually happen, when the battlefield has already begun to move past the specific failure being corrected, quietly, without attribution, filed under the general category of updated intelligence rather than the specific category of intelligence that should have been caught months earlier. Wells noticed this. He wrote about it in his personal log. Not in official documents, because he understood the difference between what an institution will record formally and what it will only allow to exist in private margins. He returned to Aberdeen in April 1945, 3 weeks before the German surrender. He received a commendation for his field work. He was given a new assignment. He accepted it and said nothing publicly. But on the day he returned, he wrote one paragraph in his log that was not technical analysis and not formal assessment. It was the kind of writing a man does when he has been carrying something for 6 months and needs to put it somewhere outside his own head. He wrote this: "The men who died between July and October were not killed by a weapon the enemy had hidden from us. They were killed by a weapon we had already decided we understood. We saw the number and we stopped looking. The enemy did not deceive us. We deceived ourselves, and we did it the moment we confused the label with the thing the label was attached to." That is not a failure of intelligence collection. It is a failure that happens the moment an institution becomes more comfortable with its existing answers than with the possibility that those answers have not been tested against the evidence that is sitting right in front of them. Wells never published that paragraph. The longer analysis of the label problem was classified and remained classified for decades. When historians wrote about the Tiger II in the post-war years, most of them described the KWK-43 as a development of the Tiger I's gun, a natural progression, a more powerful version of the same weapon. The number was the same. So they concluded the guns were related. They were making the identical mistake that had cost Allied crews 3 months of wrong information in the field. And not one of those historians in any of those accounts went back to measure the difference between a cartridge case 571 millimeters long and a cartridge case 822 millimeters long and ask what that difference actually meant. The label said 88. The file was already open. No one looked inside. Here is what looking inside actually finds. The Flak 18, built in a shadow factory in Sweden in 1928 to shoot down aircraft, fired a cartridge designed to minimize aerodynamic drag on a shell traveling upward through altitude. The KWK-36, adapted from that anti-aircraft gun in desperation after France and Russia, fired the same cartridge in a tank turret because there was no time to build something better. The KWK-43, designed from engineering first principles in 1943 to defeat armour that did not yet exist, fired a cartridge 251 millimeters longer at chamber pressures the original gun could not have contained, achieving penetration values 40% higher at every range on the table. 3 weapons, 3 cartridges, 3 completely separate engineering histories separated by 15 years and a world of accumulated battlefield experience. 1 number. That number is why the file stayed closed. That number is why the tables were wrong. That number is why Wells spent 6 months trying to get an institution to reopen a question it had decided was already answered. And that number is why, when you watch a documentary today that tells you the Tiger II carried a more powerful version of the Tiger I's gun, you are hearing the same conclusion that a staff colonel wrote in the margin of a field report in October 1944, before anyone had measured anything, when the only evidence was a familiar label on an unfamiliar weapon. The label said 88. That was enough then. It is still enough now. And that is the problem that Frank Wells spent his career trying to explain to people who had already made up their minds. This time, someone was going to read it.